A very good morning, dear students, and welcome to the class of mathematics. Today, I'm going to teach you squares and square. So, let us start the topic. The properties of perfect square. A number ending in 2, 3, 7, or 8 is a perfect square. That means a number whose last digit is 2, 3, 7, or 8 is never a perfect square. A number ending with odd number of zeros, that is, if a number has 3, 5, 1, such type of zeros at the last, then it is not a perfect square. Square of an even number is even and an odd number is odd. Square of a proper fraction is smaller than the fraction. The square of a natural number n is equal to the sum of the first n odd numbers. That means if I have a square of a natural number, likewise I have 25. So 25 can be written as 5 square. So I can express 5 square as a sum of first 5 odd numbers. That means I can write 5 square as 1 plus 3 plus 5 plus 7 plus 9. Now, the next property is the square of a natural number n is equals to the sum of the first n odd numbers. The same I have explained. For example, n is equals to the sum of the first n odd numbers. That is, I have given you the example of 25. Write 5 numbers which you can decide by looking at their ones digit that they are not square numbers. So, I have explained to you earlier that number ending with 2, 3, 7, or 8 is never a perfect square. So I have taken the numbers. You can take either 2-digit numbers, a 3-digit number, 4, 5, whatever you like. So at last the number is 3, 2, 7, 3 and 8. You can even choose a number which ends with the odd number of zeros. Likewise, you can have 5,000 or 1,000. Okay, so what will be the unit digit of square of the following numbers? 9, 6, 5, 1. Here you can see that the last digit is 1. If on taking the last digit, I have 1. So I'll have to multiply 1 2 times. That means 1 into 1, which is 1. So this unit digit, that means the last digit of the 9651 square is 1, because I have to express within the bracket that the last digit will be 1, because 1 into 1 is 1. Without adding, find the sum. Here is the property I have discussed with you. Without adding, find the sum 1 plus 3 plus 5. So the question is that you have consecutive number of odd numbers given in the question. So just count the number of the consecutive number of how many odd numbers you have given in the question. I have 15 odd numbers, so you can express the sequence of the odd numbers as 15 square, because I have 15 odd consecutive numbers given there in this question. So 15 square is 225. The converse of this question is given in the next question. Express 64 as the sum of 8 odd numbers. So I can express 64 as 8 square. So I have 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. So I have 8 odd numbers. So it ends at 15. Express as sum of 2 consecutive integers. So I have one more property, so I'll discuss here. I can express any odd number, the square of a natural number, as the sum of 2 consecutive natural numbers. So I can express 23 square as 23 square minus 1 upon 2, plus that means sum of 23 square plus 1 upon 2. So I'll have to calculate 23 square, which is 529, minus 1 upon 2, this is 528 upon 2, 264 and 265. These are the 2 consecutive natural numbers. Next is very interesting and very useful in the higher classes also. If you need to calculate a number ending with 5, so it's very easy and it's a quick game type. That if you need to calculate a number ending with 5, so you just need to write at the end 25, and what you need to do is you need to multiply the remaining number and its consecutive number and just add it to the 25. So multiply it by 100 and just add it to 25, or in the simple series I have written at last 25 and then 1 and then the consecutive number is 2. So 1 into 2 is 2. So 225. 25 into 25, 5, last digit are 25. So the remaining number is 2. So 2 into 3, the consecutive number of 2 is 3. So 2 into 3 is 6. So put 6 before 25. Same way, 95 into 95. So I have 25. 9 into 10, the consecutive number of 9 is 10, so 9 into 10 is 90. So the answer is 9025. So in my notebooks, I'll write it as at the last digit 25 plus 1 into 2 multiply 100. So I'll multiply the remaining number by 100. So I'll get the answer very easily. So this is also the algebraic proof I have given over here. So the next I have is very important, is Pythagorean triplet. Pythagorean triplet is actually the three sides of a right angle triangle. They are related to each other by the formula Pythagoras theorem. So what is Pythagoras theorem? That in a right angle triangle, three sides of a right angle triangle are related to the Pythagoras formula, that is h square equals to p square plus b square. H means hypotenuse, that is the longest side of the right angle triangle. P means perpendicular and B means base. So here I have the Pythagorean triplet. I have Pythagorean triplet of three numbers actually. So the numbers are m square minus n square to nm and m square plus n square, where m is greater than n. So these are the positive integers. But I just have simplified as the Pythagorean triplet are, so I can relate them using the Pythagoras theorem, that is h square is equals to p square plus b square. Simply if I have three numbers a, b, c, so I have c square is equals to a square plus b square. So here I have the question is, if I need to find the square root of a number by successive subtraction, so you just need to subtract in the first number by 1 and then by 3 and then by 5. The answer has to be subtracted. So minus 1, minus 3, minus 5. If at the end I get 0, then it will be the square of the number of the steps I have done to find out the 0. And if not, that means it is not a perfect square. Here you could easily see that I start with 36. That means 36 end up to 0 within 6 steps. That means the square root of 36 is 6. And yes, of course, it is a perfect square. Here I need to find the square root of a number by prime factorization. I have two methods to calculate the square root of a number. One is prime factorization and the other one is long division. I'll discuss the long division in my next video. So I have done prime factorization. It gets easily divisible by 7. So the next time it also divisible by 7, and next two times it gets divisible by 13. So I have place the symbol of the sign of square root over 80 to 8281, and then from two factors it simplified to 1 when it comes out of the square root, and then 13 into 13 reduces to 13, so 7 into 13 is 91. So 8291 is the square root of 91. Find the smallest square number that is divisible by each of the following numbers. You know that the smallest square number is the LCM, so I have taken the LCM here, but you can easily see here that it is not a perfect square. So what I need to do is to make it a perfect square. I have discussed with you in the previous video that to make it a perfect square I need to multiply it by some number. So the remaining factor here is 3, which is alone. So I just need to multiply it by 13. So just multiply 108 by 3. So what I get is 324. So here I have the answer. 324 is the number which is a perfect square, multiply and is divisible by each of the given numbers, that is 6, 9, 27 and 36. Next is a statement sum. That means in a PT, in a school assembly, a PT teacher wants to assemble 2000 students in the form of number of rows and columns, but still some students left. So the number of students that are left, that means they are not arranged in where he wants to arrange them. So I just need to subtract the number of students so that I can get the number of students which are arranged in a pattern that the number of rows and columns are equal. So the answer is 1936 after subtraction. I have taken here as number of rows and columns are equal. It is given in the statement. So x square is 1936. When square goes to the next side, it becomes square root. So by prime factorization, I have shown at the left hand side prime factorization of 1936. So the answer is 44. So the number of rows and columns are 44. The next one is I have two squares. The parameters are given to me, that is 60 and 144. From the parameter, the formula of a parameter of a square is 4 into sides. So the unknown quantity here is side. So I can just easily find out the sides of the two squares S1 and S2. I have taken here as S1 and S2. So from the sides, what the next is that find the parameter of the another square equal in area equal to the sum of the first two square. That means I have to find the parameter of a new square, and the condition is that the area of the new square is equal to the area of the next previous two squares. So from the sides I have derived from the parameters, I need to find out the areas. So I have calculated the areas. I just need to add up so that I can get the area of the new one square. So I have taken the side of the new square as S and the previous one as S1 and S2. So when I add up, I get 1521. So the area of square is S square. So when square goes to the next side, it becomes square root. So I have 3 into 3. I have shown prime factorization at the left hand side of this question. So it is very important to show factorization, prime factorization. So I got 3 into 3 into 13 into 13. From the prime factorization, I got 3, out of the square root, I got 3 and 13. So the answer is 39. But students, here is not the solution of the question, the complete solution, because I need to find the parameter of the square, the new square formed after the addition of the areas of the previous squares. So I just need to find out the parameters. So I have the side of the square. So it's very easy for you to calculate the parameter, which is 4 into side. So 4 into 39, it is 156 meter. So that's it from my side, students. Hope you like the videos. Thank you so much.